Okay, so now I'll explain how to find the minimum cost spanning tree out of this by using the Prim's method. Just this is the informal method. I'll explain to make you understand how you're going to apply the Prim's algorithm. After that, I'll give you a proper method in the form of a table how you're going to solve this problem. Okay, so this is the given graph. You're going to get the minimum cost spanning tree out of this after applying the Prim's algorithm. Okay, so how does it what do you how do you apply this Prim's algorithm? Okay, and suppose that we are going to start with 1. Okay, the arbitrary vertex, anything we can take. Suppose that we are starting with 1. Now what you are going to do is, you are going to consider this 1 has been selected now. Okay, so you have to see what are the edges connected, what are the vertices connected with this 1 through the edges. Okay, 2 and 6 are connected. Okay, before that, what do we do is, we take one set VT which contains all the selected vertices. Okay, and ET that contains all the selected edges. So in the beginning, since we are starting with the vertex 1, that is included in this VT. And what is V? V is nothing but all these vertices together, the set of all these vertices. How many vertices are there? 7 vertices are there. So 5, 6, 7. Fine. Okay. Now, so as I told you, you are going to, and this is null. Nothing is there in the beginning. Now, as we have selected 1, you have to select from among V minus Vt. That means 1, excluding this 1, from 1, which are the vertices that are connected to this 1 and which edge is having the minimum cost. So that means 1 is connected to 2 as well as 6. Okay, and 1 to 6, the edge is carrying the weight 10, and 1 to 2, it is carrying the weight 28. So what we have to do, we have to consider this 1 to 6 edge, because it is, here 1 is already selected and 6 is among the unselected vertices. This is, okay, in this V. Okay, so that's why what we are doing here, again you have to draw this. Okay, 6, this is 2, 7, 3, 5 and this is 4. So you have selected this edge. So this is 10. Okay. Now this becomes, VT becomes 1 and 6 and ET becomes, we have selected one edge, that is 1 to 6. This is the subset. Now what you are going to do, you are going to consider, it consists of 1 and 6. 1 and 6 vertices have already been selected. So what you are going to do is, you are going to check which are the vertices that are connected to these, both of these vertices, that is 1, 2 and 6, 5. Among these two edges, which one is carrying the minimum most cost, that we have to consider. Okay, so 6, 5 and 1, 2. So this is 6, 5 is the minimum cost edge. So we are going to consider in the next stage, you are going to consider, you have to draw the diagrams in each step. 3 and 5, this is 4, and now we have selected this. And most important thing I forgot to tell you is, whenever you are considering the minimum cost edge, you have to make sure that that edge is not causing the cycle in the graph, because we are going to find the tree means that should not contain the cycle. So make sure that when you are when you select that particular edge, it is not resulting in the cycle in the tree. Okay, so now this is 25. Now update this VT and ET. So VT will become 1, 6 and 5, and ET will become 1, 6. What are the edges? 1, 6 and 6, 5 or 5, 6, because it's the undirected graph. Doesn't make any difference if you write 5, 6 or 6, 5. Okay. Next, now you have considered 1, 6, 5. 1, 6, 5 have been considered. So what are the vertices that are connected to any one of this selected one? So 1, 2, because 2 it is connected, it is not selected. So 1, 2 we can consider. Then 5, 7 we can consider, and 5, 4 also we can consider. Did you understand? So we have to consider these vertices 1, 6, 5. And from here, is there any edge going to the remaining vertices? Remaining vertices are, if you take out 1, 5, 6 here, 2, 3, 4 and 7. Okay, so it is going 1 to 2 it is there, and 6 to 5, 5 to 7 is there. 5 to 6 is done, right? 5 to 4 is there. Okay, so among this 28, and this is 5 to 7 is 24 and 5 to 4 is 22. Among this, which one is minimum? 22 is minimum. So you have to consider that. So now the graph will become 1, 6, this is 2, then 7, and this is 3, and this is 5 and 4. So these are already there, 10, and this is 25, and now this is 22. Now update these two sets. VT is equal to 1, 6, 5 and 4, and ET is equal to 1 to 6 and 6 to 5 and 4, 5 or 5, 4. Okay, now from now, like 4 to 7 is there, 4 to 3 is there, then 1 to 2 is there, and 5 to 7 is also there. So that means you are considering this, then this and this. Okay, so these are all we are going to consider. Among these, which one is having minimum cost? This 12, that is 4p can be. And is it forming any cycle? No. So you can consider this edge in the next stage. So 1, this 6, then this is 2, 7 and 3, this is 5 and 4. This is 10, this is 25, and this is 22, and this is what is the value? Yeah, 12. Okay, now VT becomes 1, 4, 5, 6, 3. Okay, I should have written 3 earlier. That's okay. So ET is equal to 1, 6, 6, 5, 5, 4, 4, 3. These are the edges. Okay, now consider all these, like only 7 and 2 are left. Okay, so 1 to 2, 3 to 2 are there, and here 5 to 7 and 4 to 7 is also there. Among these, which one is having the minimum cost? 16 is having. Okay, so we can consider this cost. So next it becomes 1, 6, 2, 7, 3, 5 and 4. Now this is 10, this is 25, this is 22, this is 12 and this is 16. Is it fine? Yes. Okay, this is 16. Okay, so now also there is no cycle which has been formed. Okay, so VT becomes 1, 2, 3, 4, 5 and 6. We are left with only one vertex, so we have to select one more. ET becomes 1, 6, then 6, 5, okay, 5, 4, 4, 3 and 2, 3. Okay, now, so here 7 is there. Okay, 7 is connected via 2, 5 and 4. We can consider only these edges. Okay, so 2, 7 is carrying the minimum most cost. So we can, and also it is not forming any cycle. Okay, so we can consider this particular edge. Okay, then it becomes 1, 6, 2, 7, 3, 5 and 4, and this becomes like this. Okay, and this one. So what are the costs here? 10, then 25, 22, 12, 16 and this is 14. Okay, now if you write this, it will contain all the 7 is also included here and it contains all these edges. Okay, now what is the total cost? Total cost, the total weight of this spanning tree is 10 plus 25 plus 22 plus 12 plus 14 plus 16. It becomes 35, 45 and 67 and 89. So this becomes 89. The cost of this particular spanning tree is 89.